How many grams of H2 gas can be made from the reaction of 8.64 grams of sodium metal if the percent yield of the reaction is 55.6%? Alright, so we have a chemical reaction between sodium and water, and we know how much sodium we have. And since we only know one reactant's amount, this is apparently a stoichiometry situation. So in stoichiometry, 8.64 grams of sodium need to be turned into mole of sodium using the molar mass of sodium. Each 2 mole of sodium, according to the balanced chemical equation, is then going to be forming 1 mole of hydrogen gas. And then, of course, each 1 mole of hydrogen gas is 2.016 grams. This is a normal gram to gram stoichiometry setup. Units cancel perfectly and will give us a gram of hydrogen. The calculation here showed, if we punch odd numbers into the calculator, 0.379 grams of hydrogen. Okay, if this is the regular stoichiometry problem, this would be the end of it, and this would be your right answer. However, with the percentage yield involved, this is not a regular stoichiometry calculation. 55.6% means of all the products that's going to be made, theoretically, only some of them, to be exact, 55.6% of them would make it. So what we got here from the stoichiometry calculation, we need to remember, this is the theoretical yield. This is when every bit of our sodium reacts and turns and work effectively to release hydrogen from water. This is the maximum amount of water that hydrogen we can produce. Yeah. And the percent yield means we can't do the maximum amount. Yeah. The actual yield, which is what we want, should equal to the theoretical yield times percent yield. And 0.379 grams of hydrogen times 55.6% leave us 0.211 gram of hydrogen. So if all the 8.64 grams of sodium metal were used to produce hydrogen, and the maximum amount, the theoretical amount of hydrogen we can make is 0.379, but since the percent yield is only 55.6, which means a whole bunch of the reactant used were basically wasted, we're only going to get 0.211 grams of hydrogen from this reaction.